pH is a measure of how acidic or basic a solution is. pH ranges from 0 to 14, and pH measures the amount of free hydrogen and hydroxide ions present. A solution is acidic when the pH is less than 7. This is because the concentration of hydrogen ion is greater than the concentration of hydroxide ions. A solution is neutral when the pH equals to 7. In a neutral solution, the concentration of hydrogen ions equals the concentration of hydroxide ions. A solution is basic when the pH is greater than 7. This is because the concentration of hydrogen ions is less than the concentration of hydroxide ions. There are various ways to measure pH by using acid-base indicators, by using pH paper, and also using pH meter. This image shows the pH scale from 0 to 14 with different substance and materials with their respective pH. For example, vinegar has a pH of 3, therefore it is acidic. Water has a pH of 7, therefore it is neutral. Soap has a pH of 12, therefore it is basic. Now, let us look at the term pH and pOH. Do you know that we can calculate a pH value? pH can be calculated by using the formula pH equals to the negative logarithm of the concentration of hydronium ions or the concentration of hydrogen ions. The higher the concentration of hydronium ions or hydrogen ions, the lower the pH value. Similarly, pOH can be calculated by using the formula pOH equals to the negative logarithm of the concentration of hydroxide ions. The higher the concentration of hydroxide ions, the lower the pOH value. Here, let us look at the dissociation of water molecules. Two water molecules are capable of reacting with each other to give a pair of hydronium ions and hydroxide ions, as shown in the equation. Only a very small portion of water molecules undergo this reaction. Therefore, water is a weak electrolyte. This kind of reaction is called auto-ionization reaction, as two ions are produced from a neutral species. Kw, a constant which is called the ion product constant for water, or sometimes called as ionization constant of water, can be expressed as the product of the concentration of hydronium ions and the concentration of hydroxide ions. Kw has a value of 1 times 10 to the power of negative 14 at 25 degrees Celsius. In pure water, the concentration of hydronium ions or hydrogen ions equals the concentration of hydroxide ions and therefore has a concentration of 1 times 10 to the power of negative 7 molar. As we are familiar with the terms Kw, pH and pOH, let us look at how these terms are related. As we know, the concentration of hydronium ions and hydroxide ions are interrelated by the expression Kw equals to the product of the concentration of hydronium ions and hydroxide ions. By taking the logarithm of both sides and multiplying by -1, we obtain the following expression. By substituting the value of Kw, which is 1 times 10 to the power of negative 14, the following is obtained. Therefore, as negative log Kw equals to pKw, negative log concentration of H plus equals to pH and negative log concentration of OH negative is pOH, the following is obtained. Therefore, pH plus pOH equals to 14 at 25 degrees Celsius. The relationship between pH and pOH equals to 14.